what I have in front of me is the end of the first lab of computer graphics. It might look a little different by the time you see this video if Shri reuses these for a long time, but we'll see. So in the year of our Lord 2023, this is what the first lab looked like. It was just draw one triangle and that was it. We've got an HTML file and a JS file. I spent a little bit of time in kind of tidy them up, bring them up to modern HTML JavaScript standards, but that'll be a topic for another video on making our web stuff nice. But it's like as simple as it could be, right? We have a shader that takes in a position and spits out F color, whatever. What I'm going to do is go through this basically line by line and explain what's happening. I'm going to basically draw GL as if it's a little thing on my whiteboard, and we're going to walk through what's happening here. So first couple lines are kind of not really related to GL. We kind of grab the canvas from the web page, pulled our GL context out of it, and then we define where we want our points to be on the page. I've done mine as a little two-dimensional array here. So I've got each one is basically like a two-dimensional vector, right? And my X and my Y. I could even, make a little X, Y, and I might like line these up sometimes. I like to do that. Because eventually I might start adding more attributes, but we'll get to that. So first thing that we do, we GL viewport and clear color are kind of hard to, I can't really diagram those, but I think they're self-explanatory enough. X, Y, width, height. If ever you were drawing, if you wanted to, for whatever reason, you could render to like the bottom right quadrant of this canvas. This lets you configure where on the screen or where in your area you're rendering to. This will come up once we start using textures and drawing WebGL graphics into a texture. But for now, that doesn't come up very much. Program and use program, not super complicated either. That's what I covered mostly in last video. Is these make the two shaders. These compile. This two lines compile these and tell OpenGL to make it the active program. And as far as making things active, again, we'll get to that in a second. Now this part is where things get a little quirky. So this is just more JavaScript level stuff. This is me turning my array of arrays into an array of just numbers, and then I turn those into raw binary floating points. The little common library that Shri's been using, or from the textbook, I think actually, does have a function here called flatten that does both of these in one. But in an effort to kind of you rely on that as little as possible, I've took that out, and I just uses init shaders is the only program from that helper library that I'm using. So basically, this is the meat of what it takes to draw a triangle, plus obviously the shaders. But something like I said at the start of the last video, the point of these videos is mainly to kind of clear up misconceptions. And something that I saw a lot was that when the second lab asks to draw a second triangle, I would just see people, duplicate everything. Not exactly that extreme, but you get what I'm getting at. I'd see everything copied, and so I'd see 2 vertex shaders and 2 fragment shaders, which if you think back to how I explained the fragment shader or the pipeline last time, if it's called a program, I think that makes it pretty clear that, if you want to draw 2 things using the same series of steps, the same program, you only need it once. You just call it with different things, right? Like if you had a function, or you had even like some C, like some binary that you were going to call in the command line, you wouldn't compile a second version that has different parameters inside of it. So anyways, hopefully I can make it a little clearer what's actually happening in these last little bits here. So let's switch to my little webcam. So basically, we're going to pretend that this whiteboard is OpenGL. When we start by compiling our program, setting our viewport and stuff, like I said, that part of OpenGL we're going to kind of ignore. We're just focusing on the create buffer and the dreaded vertex attribute pointer. So when we call, first off, we're going to pretend that OpenGL has this little box down here, where when we call use program, does that show up on camera at all? Yeah, a little bit, more or less. Maybe I want to do most of my stuff in black, actually. Wow. Yeah. That probably shows up better. A little bit. So down here, we've got a little box that stores, wait for it. So when I call use program, it looks at the inputs of the vertex shader that in a position, and that is, like I went over last time, or like I mentioned last time, that's the vertex attribute. The little my triangle, and if this needs if deciding where this point is going to go requires 600 bytes of data, then those 600 bytes would be our vertex attributes in here. But in our case, we just have one, and it's called a position. A position. So right now, it's kind of like, a position is some nothing. I need to get my little example up here. So the first thing we do, buffer ID equals gl.create buffer. Back to the camera. Did that work? Control that one. Yes. So the first thing we do is we call create buffer. And naturally, that makes a buffer. So in our OpenGL little model up here, that's way too wide. We got little square brackets up here, and I am really bad at drawing straight lines, apparently. There we go. So there's our buffer. Done. Awesome. You made a buffer. Something to note is that OpenGL is what's called a state machine, which is just a fancy way of saying that, for our purposes, just a fancy way of saying that you can't access this buffer. When you call create buffer, it makes some buffer, and it spits out that, okay, that's buffer, buff ID number, I don't know, that's buffer number, probably is going to start at 1, I think. Can I make that a little bigger? Oh, that's way better. So there we go. So it makes a buffer, and it gives us this 1. And then when we want to do stuff with this buffer, we have to have some way to tell OpenGL that, because again, we can't just access things on the graphics card. OpenGL gives us a bunch of functions to access them. So one of them would be something like .buffer data. So, hey, OpenGL, please set data in some buffer. But to do that, if the function is just buffer data, we have to have some way to tell OpenGL that, for the foreseeable future, buffer-related operations will act on this buffer. So what we do is that's what actually, Control 1. There we go. That's what this one does, bind buffer. And you'll notice this little array buffer thing here. That's because there are multiple buffers in OpenGL. This says, for all buffer-related things in the future, use buffer number 1. But, for all array buffer-related things in the future, you can bind other buffers for other things. But, that's what that does. So the way I'm going to represent that on my little model here is that when I call bind buffer, so let's say that this is buffer number ID, so number 1. So there's buffer 1. When I call bind buffer, or a buffer 1, then this one gets bound as the current buffer. And so OpenGL now kind of like, okay, that's the current buffer. And now when I call buffer data and pass it in some floats, it knows, oh, what buffer is currently bound? This one, okay, it goes in here. So in our case, we passed in negative 0.5, whatever. negative 8.5. So we passed in, that's this one, and then this one, and then this one. So we passed in 6 numbers, x, y, x, y, x, y. Back to the show. And then, so in here now, what we end up with is x, y, x, y, x, y. And that's our buffer data. So that's the first 3 lines. We make a buffer, we bind a buffer, and then we set some buffer data. And then next 3 lines are where a lot of people get really tripped up. So here, a position is, I do not need that. A position is get attrib location, vertex attrib pointer, enable vertex attrib array. This line here, you can think of as, remember here where I said OpenGL just kind of, this little black box down here, it knows, now that I'm, when I told it to use my program, it looked at it and it saw that there was an A position. When it did that, it kind of, just like the buffer, just like how this was number 1, it actually put a little, this is, vertex attribute number 1. But it doesn't tell us that it's number 1. We can guess that it's number 1. I'm pretty sure if I actually put a 1 in that, it'll still work. But what get attrib location does is it says, hey program, what number did you put for A position? Because I don't know what it is. And then we can use this number to do vertex attrib related things to that one in the future. And that's all it does. So that's something that I see copy pasted all over the place in students' programs that's not necessary. Because the program's only ever going to put A position in one spot. So once you load your program, you can kind of make A position's location a global variable. And we'll get to an example later where you actually don't even need to ask the graphics card at all. You can tell the graphics card what you want it to be, and then you can just use the number in your own code. But whatever. So that's what that first line does, is it asks the graphics card for this number. Next line, vertex attrib pointer. That's like the whole point of this lecture. Haha, point, get it? So what we want to do to be able to draw our triangle is to, I think, it's hard to quite remember exactly how much detail I went into last time, but what we want to do, so we have our vertex shader, right, our pipeline. So there's our vertex shader, and then there's our fragment shader. And we want to feed in arbitrary data, send something to the fragment shader, and then get a color out. In this case, we're just always going to spit out orange from here. But what comes out here as a side effect, the GL position, that is going to be computed from our arbitrary vertex data. In this case, the vertex data is made out of just one A position, which in the shader we said was a vec4. But you'll see in a second that we can give it just 2 floats, and the other ones will auto-populate with some same default values. So we need some way to tell the graphics card. Like I mentioned last video, it's super parallel. So what it's going to want to do is when we tell it to draw 3 vertices, it's not going to do 1 and then 2 and then 3. Each vertex is going to get drawn at once. So the graphics card needs, or well, not at once, but in parallel. So the graphics card needs to be able to figure out, okay, this thread is finished its rendering job. I need to give it some new vertex data. Let me throw in the vertex data for vertex number 892. It needs to know how to read through our buffers to get to that vertices data, vertexes data. So we do that by saying vertex attrib pointer. And that function looks at the currently bound array buffer. So remember, you can have other buffers bound, but the one that matters for this function is array buffer, which I've done in green. Looks at the currently bound buffer, and then uses the offset parameter, which in this case is 0. And it says, in this case we said it's 2 floats. So A position, let me pull that back up. So here we can actually see. A position is 2, type is float. We don't want OpenGL to normalize them. Stride is 0. We'll get to stride in a bit, but we can assume that'll always be 0 for the next couple of videos. And then offset is 0. So offset means that, hey OpenGL, whatever buffer is bound right now, we go to, byte offset number 0. And that's how you get to the first vertex pointer. Stride of 0 says that to get to the next one, jump forward by exactly the size of whatever I told you it was going to be. In this case, I told it was going to be 2 floats. So that's a offset of 0 from the start of my buffer with a stride of, technically, stride 0 means figure out the stride for me, please. But this is my stride here of 2 GL floats, which is actually 8 bytes, because the float is 32 bits. So that's what that function does. And so once this little arrow is here, we can call gl.drawArrays. Actually, we need to enable it first, but hopefully that line is self-explanatory. Enabling this one just kind of says, okay, next time I call draw arrays, you're going to read that one. If you had, again, you might have a billion of these for whatever reason, you can disable and enable some on the win, on a win. So I guess I don't need these anymore. That's kind of my visual for what's happening here, is that it's setting a position as an arrow into this little buffer here, and then we call draw.